Today we are going to solve this problem, counting bits. Let's first read this problem. So there is an integer n that is given. We have to return an array answer of length n plus 1 such that for each I from 0 to n, answer of I is the number of ones in the binary representation of I. So let's look at some the test cases. Test cases are n equal to 2. For n equal to 2, the answer array is 0, 1, 1. Means that uh, for n equal to 2, we have an array of 0, 1 and 2. Now 0 is represented as 0 only, so the number of ones is 0. 1 is represented as 1, so the number of 1 is 1. 2 is represented as 1, 0, right? So the number of 1 is 1 only. So that's why the array is 0, 1 and 1. Similarly, for 5, we have 0 and 1. 0, 1, 1 up to 2, and then for 3 we have 1, 1, so there are 2 ones. Then for 4 we have 1, 0, 0. The binary representation of 4 is 1, 0, 0. So that's why here the number of 1 is 1. For 5 it is 1, 0, 1. So the number of 1 is 2. So one way of solving this is basically creating an array, going through all the elements, like all the indexes of the array, and for each index we can count the number of ones present in that index, right? So that is one way to solve this problem, and the time complexity of that particular algorithm would be order of n into 32. Not 32 actually, but we can say into log n, because a log base 2n. Why? Because we'll go through the whole array of size n plus 1, or you can say n, because answer of 0 will always be 0, right? So we can we'll go through all the elements of an array of size n, and for all n, what we'll do is we'll go bit by bit for that element, and for that the time complexity is order of 2 log n base 2, because if we divide by 2, we'll just go to 1 bit by bit. So this is the brute force solution, but here you can see that there are some follow-up questions, which is can it be done by order of n time, which is a linear time, and possibly a single pass. And you cannot use the built-in function. So there is a built-in function, this dash dash built-in dash popcorn, which gives you the count of the set bits, or the bits that are 1 in an integer. So we cannot use them. We have to use a single pass algorithm with order of n linear time. How can I do that? Let's see. So let's consider n, the possible, or let's say I, right? I is what? I is less than equal to n, greater than equal to 0. So at any index I, there are two possibilities of I. One is it can be even, and another one is it can be odd. So if it is an even, then we know that the last bit will be 0, right? There will be bits like 1, 1, 0, dot, 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 any bits. That is not the factor. The factor is that the last bit is 0 or 0. Similarly, for odd, we can say that there will be some bits somehow, but the last bit has to be, right? So if I set apart this part and we only focus on the last bit, similarly here, if we ignore this part and similarly focus on the last bit, then what you can say? We can say that the number of ones in this number will be, like in this whole number, the number of ones in this whole number will be equal to the number of ones that is present here in this part, removing this 0, right? Because if we remove this 0, the number of ones is still the same. Similarly, for odd elements, we can say that the number of 1 in this number, this whole number, is equal to the number of ones in this small number plus 1, right? So we can say that. So what it says, like, so now what we need to do is we need to find the number of ones present in the smaller number. So this is like a sub problem we have now. So what you can do is, this is, so what this hints is, this is kind of a recursion algorithm we can use, right? Which I have some problems. So instead of using a top-down approach, you can use a bottom-down approach to make this recursion a DP solution. So what you can do is, for any I, let's say DP of I stores the number of digits that are present in I. So for any I, what we can say is the DP I will be DP of I right shifted by 1, right? We will right shift the bit by 1. Basically we are cancelling this bit and we are taking only this integer, or it will be dp of I right shift by 1 plus 1, right? This will happen if the number is, if I is even, and this will happen if I is odd. Also I right shifted by 1, we can simply represent it as I by 2, both are same, right? So what you get is that the answer of I'm taking answer because it is so saying that the answer will be answer of I by 2 plus 1 if this is if I is odd, or answer of I by 2 if this is an even. So like this, if we traverse from 0 to n, then for any index I, we'll always know the answer for I by 2 because we have already computed it. So using this function, we can find it in order of n time and a linear space. So now let's code this. So first I will create an answer array of size n plus 1, and we'll say I equal to 1 to I will take in plus plus if I mod 2 is equal to 1, means it is an odd number. The answer of I will be answer of I by 2 plus 1, else if it is an even, then answer of I is equal to answer of I by 2, and we can return that. Let's take a sample test case and write on it. So let's say 5. So let's say that the n is 5. Now what will be the answer? Answer is, let's say there are 5 zeros. First I will be 1. It will go where I mod 2 is 1 mod 2 is obviously 1. So it is an odd number. Answer of I by 2 is 0. 1 by 2 is 0. Answer of 0 is 0 here. And I will add 1 here. So the resultant will be 1. So answer of 1 will become 1. So this will become 1. Now I will become 2. This will go to this else statement where answer of I will be answer of I by 2. So 2 by 2 is 1. So answer of 2 will be answer of 1. So this will be 1. Then I will become 3. Then it will be odd here. So it will be 3 by 2 plus 1. 3 by 2 is 1. So answer of 1 plus 1. Answer of 1 is 1. So answer of 3 will become 2. Then I will become 4. And it is an even number. So answer of I, like answer of 4 will be answer of 4 by 2, which is answer of 2. Answer of 2 is 1. So it will become 1. And then I will become 5. It is still equal to n. So it will go there, it will go inside the loop. It is an odd number here. So it will be answer of 5 will be answer of 5 by 2. 5 by 2 is 2. So answer of 2 plus 1. Answer of 2 is 1. Plus 1 will be 2. So 5 will become 2. And then it will become 6. 6 is not less than equal to n. So it will break, and the answer, the value of the vector will be returned. So the vector that will be returned is 0, 1, 1, 2, 1, 2. As you can see, 0, 1, 1, 2, 1, 2. Let's check for one edge case that if the n is 0, then definitely the loop will not run and it will be returning a 0 again. So now let's submit this, let's see what happens. So this is accepted.